Okay, welcome to another Ginger Mathematician video where I'm going to go through all of IGCSE on vectors. I've had a couple of requests for this, and if you're liking the kind of content I'm doing, then please do like and subscribe. Liking being the most important thing, because it tells the algorithm, spread it to other people and spread the word. Right, let's get started. So this is question 12, and we need to write the vectors P, Q, and R in terms of A and B. So these are our basic vectors, so to speak, down the bottom here, and then we need to work out the combinations of them that give us the vector P, the vector Q, and the vector R. And let's have a look at this first of all. Well, I'm going to start at the bottom here. Let's add on an A vector. Now to go A, we need to go 1 to the right and 2 upwards. So we need to go 1 to the right and 2 upwards. That comes to here. So that gives us vector A. And then what do we do from here to get to the end of vector B? Well, we have a perfect vector for this, which is vector B here, which is 2 to the right. So we're using the so-called parallelogram law to actually work out what's going on here. So to go from the start of P to the end of P, we need to go plus A and then plus B. Remember, the direction is very important. So P is equal to A plus B. Now notice this squiggle I put underneath the A and the B, that indicates it's a vector. Now generally speaking at IGCSE they won't be taking marks off for it, but if you're going on to IB and A level then they certainly could. So make sure when you're doing vectors, when you see this bold type on your exam, that you're putting a squiggle underneath to indicate it's a vector and not a scalar. Now Q is a little bit more tricky, but let's just go through this in the same procedure. So we want to go from here to here, and we need to work out what combinations of this will work. Well, let's start with A first of all, which is 1 to the right and 2 upwards. So that comes to here. So that's one lot of A. If we do it again, we go 1 to the right and 2 upwards. So that's 2 lots of A. So I'm just going to write in these as we go along. And then we've got that perfect vector going acrosswards, which will be vector B. So we're looking for combinations that go from the start and then to the end. And notice we've got 2 lots of A, so A plus A is equal to 2A. And then we've got the plus B at the end. Because we're following the direction of the arrows, that's why these are positive and not negative. Now we've got a trickier question here with R. And again, we still approach it in the same way. So here's our start point and here's our end point. Right, well, we need to go backwards to this. So notice we can actually go 2 down and 1 left using this. So notice when I put this in, I'm going to indicate this is a negative A because I'm going against this arrow. And we can do the same thing again here as well. So we can come down to here. This just takes practice. You're going to see a few of these questions on what we do today. And now we want to go from this point to the end point of R. So that's that vector we've been using quite a lot here. But remember, we're following the arrow, so it's going to be positive B. So to go from here to here, we've got minus A, that's minus 2 lots of A. And then we've got our plus B, so we need to pop in the plus B there. And you'll see this on various past paper questions that this kind of thing comes up where you have to break down the vectors into different parts. So do go through that question again if that was a little bit confusing at the start, because it's worth practicing this skill when it comes up. You can see the mark scheme there, of course, or equivalent is absolutely fine. Say you wrote B minus 2A, that is also fine too. Right, and on to quite a typical vector question, particularly on a paper 4, and ABC is given as a triangle. AX, so this AX is 2/3 of this entire length AC, so that's worth indicating here. So I'm going to put a red line here and put 2/3, just to remind myself. And AD is half of AB. Okay, so again, I'm going to put a red line in here just to remind myself that this is half the entire length. AX is equal to 6P, which we're already told here, and DX, so this vector here, is equal to Q. Find an expression in terms of P and Q for the vector AD. Okay, so you want this direction here. Now to go from A to D, we'll have to take any route, that's absolutely fine. I think the easiest route is to go from a to x and then x to d. So I'm going to write that a to d is the same as going from a to x, using the same notation with the arrow indicating what direction I'm going, plus the vector xd, going from x to d, taking the long way round, as it were. Now the vector ax, we're told in the question, that's equal to 6p. And then the vector xd we have to be careful of here, because remember, going from x to d, not d to x, so we're going the opposite direction to the arrow, so that's going to be equal to minus q. So that's going to be our final answer, 6p minus q. Remember those squiggles underneath, and I'm going to write this next to the half I wrote in. So this vector a to d in this direction is equal to 6p minus q. Now the next vector we need to work out is the vector d to c. So the vector d to c is, let me do this in a different color. Let's use, what should we use? Let's use that color. I don't know what that is. Is it green, I think? So d to c is this one here. Of course, in your exam, you're going to have a ruler, and we want to go in this direction. Now the first thing that comes to mind here is taking the so-called long route around, so going from D to A and then go from A to C. So when I'm doing this for the examiner, I'm going to make it very clear I want to go from D to A and then A to C. So I'm going to write that in. So D to A and then A to C. And let's have a think about what those vectors are. Now we know the vector a to d from the previous question, but if we want to go from d to a, we need to switch the signs. So this is going to be instead minus 6p plus q. So whenever you're switching direction, you switch the signs. And let's work out what AC is here. Well, remember, this is 2/3 of the entire length. That's why I wrote in 2/3. So if this is 6p and this is 2/3, then when you think about what the entire length will be, to go all the way from A to C, and that's going to be equal to 9p. One way of thinking about this, if you're not sure where the 9 comes from, 2/3 is equal to 6 lots of p, so 1/3 will be equal to 3 lots of p, so 3/3, or the entire line, will be equal to 9p. So I'm just using the proportionality, or times it by 1.5, to give me this as 9p. So I'm going to pop in the 9p over here. And at this point, this is just a collection of like terms. So minus 6p plus 9p is equal to 3p. And then the plus q, we can't collect up p's and q's together, so we leave it as is. So we get 3p plus q as our final answer here. And then 3-mark question, so probably going to be a little bit more complicated, is the vector cb. So let's pop in cb. So from here to here, again, direction is important. So let's draw in this as an arrow. Okay, so the first thing that comes to mind is taking the so-called long route around. There's a couple of different ways of doing this. Since we've already worked out D to C, that was the previous question, what comes to mind is actually taking the following route, which I'll do in purple, is actually going backwards to that vector we just worked out. So going from C to D instead, and then we can go from D to B here. I think we could take the very long way around as well. This would also give you the correct answer, but I think this is the cleanest way of going. So we've got C to D, just to remind myself which vectors we're taking here, and then adding on the vector dB. Now you might be thinking at this point, we don't know the vector dB, but we actually do. So, and this is where we exploit the fact that AD is a half of AB. So in terms of vectors, this vector AD is the same as the vector DB. It goes in the same direction and it's the same length. So we actually know that this is 6p minus q from question A. The vector C to D going in that direction, well, we worked out DC already, which is 3p plus q. So CD will be minus 3p minus q. So I'm trying to use the previous parts of the question to help me here in order to work out the right answer. So let's pop this in. So we've got minus 3p minus q plus 6p minus q. And then if we collect up like terms here, minus 3p plus 6p is equal to 3p. And then minus q is equal to minus 2q. Careful with negative numbers. So we get our final answer here of 3p minus 2q. So one key thing about these paper 4 style questions is try and use parts A and B to help you lead your way through to the correct calculation for part C. Try not to double up on any work. Of course, some of you at home might have gone from C to A and A to B, which is absolutely fine as well. Or even taking a shortcut C to X next to D. I think that would be a bit more complicated, however. Okay, so that's the mark scheme there, so you can check through exactly what I've done. They've taken exactly the same approach as I did here with this method marks here. And I think it's the most straightforward approach as well. Right, on to question 10. So this is a short answer question. So P is equal to 6, 3. And we need to find, well, we'll talk about that now, giving your answer in the form 3 root A. So as soon as you see these two lines with vectors, this means the magnitude of the vector. So when we have a vector question and you want to have these two lines, now sometimes it's referred to as the modulus, the absolute value, but in vector terminology we talk about the magnitude. And as soon as we see those two lines and think magnitude, we need to be thinking Pythagoras. Essentially it wants us to work out the length of the vector. So if I just visualize what's going on here, remember this is 6 to the right, so that's what the top number tells us. And this tells us 3 upwards. So if you draw a quick diagram here, essentially we've got 6 going this way and then 3 going upwards. So this is a representation of the vector P. And in order to work out the length of the line, we're going to use, as I've indicated here, Pythagoras. So to work out the magnitude of this vector, we can do this in one very simple calculation, which is the square root of 3 squared plus 6 squared. So this is actually going to turn into a surd question. Again, if you haven't checked out my all of IGCSE surds video, please do that in my playlist. Let's work this out though. So we've got the 3 squared, which is 9. 6 squared is 36. 36 plus 9 is equal to square root of 45. And this is where our simplifying surds come in for the second mark. So we're looking for square numbers 1, 4, 9, 16, 25, 36, any of these that fit into 45. Okay, well 36 doesn't, 25 doesn't, 16 doesn't, 9 does. So we need to break this down into something times 9. So we have 9 times 5 gives us 45. Now at this point we're allowed to split the surd. So we have the square root of 9 times the square root of 5. And then we can simplify it into the form that they want us here. So 3 root A, because the square root of 9 is equal to 3, root 5 stays the same, and that's going to be our final answer. So 3 root 5 is what we're looking for. This comes up more often than you think, particularly short answer questions, where they give you a vector and you have to work out the magnitude. Right, there's the answer for you, and let's move on to our next question. So again, this is a very typical paper 4 style question, question 11 here. So in the diagram, OA is equal to A, OB is equal to B, M is the midpoint of AB, and then N is the midpoint of AM. Okay, so just to remind myself here, so if I draw in this line here, this is going to be equal to a half, so half of the line, and then because you've got a half of a half, that's equal to a quarter. So each of these sections here is going to be a quarter each. So just to remind myself and tick off that I've actually used this information for later in the question. And now we need to find each of these vectors in terms of A and B and give each vector simplified as always. So we want to go from A to B. First of all, now to go from A to B, we need to go from A to O and then O to B. So we're always looking for the so-called long way of working this out. And this is where we have to be careful of the direction. Now because we're going from A to O, not O to A, this is going in the opposite direction to the arrow, so we want a negative A, but in this one here from O to B we're going in the same direction as the arrow, so we want a positive B. So our answer here will be minus A plus B, or you can flip it around and put B minus A, that's also fine. Now we want to work out what the distance is from A to N. Well, as I've indicated here already, this is why I wrote it down here. This is a quarter of the entire vector. So AN is a quarter of the entire vector from A to B. Now, luckily, in the previous question, we've actually worked out what A to B is. So that's equal to minus A plus B. So I'm just going to substitute that in, replace the AB with minus A plus B. And then if I expand out the bracket, again, just normal expanding of brackets, we then get minus a quarter A plus a quarter B, like so. And then we can pop that over as our answer. In 1 mark question, it shouldn't involve too much calculation. And now we need to work out the vector from O to N. Okay, so to go from O to N here, again, we want to break this down into the long way. So we want to go from O to A and then A to N. So always try and use the vectors we've already worked out here, because notice we're using the vector AN from the previous question. So the vector O to A is equal to just A. We're following the arrow. AN we already know from the previous question. So we get plus minus a quarter A plus a quarter B. And now we need it simplified as it says in the question here. Now remember, A on its own is the same as just 1A. So we can collect up the A's here. So 1 minus a quarter, that's equal to 3/4 A. It's like 4, basically the calculation I've done here. Let me write it separately. This is the same as thinking about 4/4, a whole one, minus a quarter, well, that's equal to 3/4. And then the B we have to leave alone, because we can't collect up A's and B's together. So we pop that in, 3/4 A plus a quarter B as our final answer. Question B is a nice little twist. So I haven't seen a question much like this, but I think it's quite an interesting one. So O is the point 0, 0, so that's going to be our origin point. And we're told the vector OA is equal to 8, 0, so 8 to the right and 0 downwards, and OB is equal to 2, 6, so 2 to the right and 6 upwards. And we need to work out the coordinates of N. Now, let's think about what OA and OB stand for. So essentially, OA is that vector A. So vector A is equal to 8, 0. And the vector OB is what we call a position vector. If you do IB or A level, it's just equal to B. It's going from O to B. So let's write it in notation we're probably a bit more used to. And now it wants the coordinates of N. So when it's asking for the coordinates of N, essentially what it's asking for is the vector ON. Okay, that is a so-called position vector. I don't know whether we actually say that on the course, on the IGCSE course, but it's useful knowledge for later on anyway. So essentially, the coordinates of N is equal to this, essentially, the vector ON, and then we convert it into a coordinate. So we already know what the vector ON is from the previous question. Again, these paper 4, they like to lead on. So it's 3/4 A plus 1/4 B. So I'm just copying down from what we've done before. And now all we do is substitute in the A and B. So we have 3/4 of 8, 0 plus 1/4 of 2, 6. So the first thing we need to do is multiply by the scalar. So 3/4 of 8, well, that's equal to 6. Again, there's a couple of different ways you can work that out. Anything times by 0 is 0. And then we have to think about this one here. So a quarter times 2, that's equal to 2/4 or a half. So let's call that 0.5. Let's keep it the decimals. And then a quarter times 6, that's equal to 6/4. Now remember, 6/4 is the same as 3/2 or 1.5. So this is equal to 1.5. And once we've done that part, we can just add together the two vectors. So 6 plus 0.5 is 6.5, and then 0 plus 1.5 is 1.5. And of course we can't leave it as a vector because they want the coordinates, that's given in the question, so we then just write it into the two gaps. So 6.5 and 1.5. So that's a nice question of understanding that actually OA and OB are vectors we already have. The coordinates of ON, we just need to find the position vector and convert it to a coordinate. So essentially we need to work out what ON is in terms of actual numbers. So I like that question. It's a nice little twist on the typical vector question you usually encounter. Okay, and you can check the mark scheme here and where you pick up all those method marks. Right, on to the next question, question 4. So first of all, we want to work out the column vector, a half of P. So the way we do that is very similar actually to the very last question we did. So you want to find a half of this vector here, which is -3 and 2. Now I suspect they do want this in decimals. Generally vectors you do. So a half times -3, well that's equal to -3/2, which is the same as -1.5. So this will be -1.5, and then a half times 2, well that's equal to just 1. So that gives us the column vector there. So -1.5 and 1. Now a slightly more complicated calculation, the column vector q minus 2p. So q is equal to 4, 3 minus 2 lots of -3 and 2. So careful with those negatives at this point. And let's just work out this part first. A little bit of bid maths. So 4, 3 are going to leave alone for the time being. Let's work out what this is. So -2 times -3, that's equal to +6. And then -2 times 2, that's equal to -4. And then we just put this together, and that gives us 6 plus 4 is equal to 10. And then 3 minus 4 is -1. So 10 minus 1 goes in our gap. And now, as I told you, this comes up quite often. So as soon as you see these signs, this means the magnitude of the vector. And as soon as you think magnitude, you need to be thinking Pythagoras. And another clue in the question here is when they say leave in surd form. Again, that's another clue that Pythagoras is to be needed. So we need to do Pythagoras on this. Now just we have to be very careful with our brackets. So when we put in the -3 here, we need to make sure the brackets are around the -3, because that's going to come positive. So -3 all squared plus 2 squared. This becomes then -3 all squared is 9. 2 squared is equal to 4. And then we get our final answer, because this can't be simplified, as the square root of 13. So we pop that in. Notice this can't be simplified because here 13 is a prime number and there's no number. You can break it down with 4, 5, 9, 16 or any other square number. And then on the next part here is we need to work out the vector AB is equal to P plus Q, and then mark and label point B on the grid. So we're starting from A. So first of all, I'm going to work out what P plus Q is. So I'm going to write it over here. So P plus Q is equal to -3, 2 plus 4, 3. Add that together. -3 plus 4 is equal to 1. 2 plus 3 is equal to 5. Now in terms of drawing this, remember the top number tells us to go 1 right because it's positive. And the bottom number, because it's also positive, is 5 up. So we start at A, we go 1 to the right, and then go 1, 2, 3, 4, 5. And then we draw our arrow like so. Label point B on the grid. So notice, follow the instructions of the question. And then we pop in that vector. So this is going to be our vector AB. Again, you can even show the examiner that this is 1 to the right, and then 5 upwards, like so. Okay, so you can check the mark scheme again, so have a look through where we pick up the marks. B1 for vector 1, 5 drawn. Okay, if you didn't do it from A, you can still get 1 mark out of 2. Right, moving on. So on to question 7. So Q is the point 3, 7, and PQ is the vector -6, 3. Find the coordinates of P. Now, whenever I do a question like this, I always draw a diagram just to represent the situation that's going on. So I'm going to draw a quick grid. I'm going to do this down here, just got a bit of space, just so you can see what's going on. So this is my grid, this is Y, this is X. First of all, we've got our point Q, so 3, 7. Let's make it roughly to scale. Again, it's fine if it's not exactly to scale. And we have the vector PQ, but that's not very helpful for us because we don't know where P is, but we can work out the vector QP. And remember that trick, if we reverse the direction, we flip the sign. So this becomes then 6 and minus 3. Once we know that, then we can just work it out from here. So let me do this in a different color. So Q to P, remember our instructions here, this is 6 to the right because the top number tells us left and right. The bottom number, because it's a minus, tells us to go 3 down. So what we're going to do here is go 6 to the right and then 3 down. So let's just put that in. And as soon as you draw a diagram, the whole thing makes a little bit more sense. So let's think about where this new coordinate is. Well, we've started at 3, we've gone 6 to the right, so that's gone to 9. And we started at 7, we've gone 3 down, that's going to end up at 4. If we look at our diagram, that makes conceptual sense as well. This looks roughly like 9, 4. So we pop that in. And now we need to find the magnitude of the vector. I told you this comes up again and again because of those two lines. And again, we need to use Pythagoras. You're probably fed off of me keep saying this all the time. One thing to watch out in the question here is the simplest surd form. So when we do get our surd, we need to simplify down. So again, we need to use Pythagoras. So PQ, or the magnitude of it, we're going to use Pythagoras. Remember, the minus 6 needs to go in brackets. It's really important. So we're going to use that Pythagoras process. And then let's work this out. So minus 6 squared, that's equal to 36. 3 squared is equal to 9. That gives us then the square root of 45. I think we just did a question with simplifying square root of 45. So remember, we're looking for all those square numbers that could or could not fit into it. 36 doesn't work, 25 doesn't work, 16 doesn't work, but 9 does. You probably remember this from before. So we need to break this down to two numbers that multiply to give us 45. That's going to be 9 and 5. And then we can separate this out. I'm kind of running out of space, but I think I'm going to get there. And remember, the square root of 9 is 3. You've seen this process in one of the previous questions as well. And we get to the 3 root 5, which is what we wanted. Check the mark scheme, and you can see you pick up the method mark for writing that root calculation that we did, and then simplifying from root 45 to our final answer gives us that 3rd mark at the end. Right, let's continue. So we're on to question 10, and the point 1, 2, and 7, 5 are shown. I tend to write in those points. And the first thing we need to do is write AB as a column vector. So I'm going to draw a line in. And now we just need to work out what's going on here. So this is kind of working backwards to one of the previous questions that we've looked at. Draw this in, this right angle triangle. Right, so let's think how far we go left or right and up and down. Well, we're going from A to B, so direction is important. Let's look at the x coordinates. So we start at 1, we end up at 7, so we're going to go 6 to the right, and then we started at 2, we go up to 5, so this is going to be equal to 3. So our column vector is going to be equal to positive 6, because we're going to the right, and then 3 upwards. So we get our column vector of 6, 3. I just looked at this question and go, oh, we've already done this kind of question already. Calculate the length of the line AB. So as soon as you see length of the line, you need to be thinking the magnitude of it. And yeah, you know it means Pythagoras again. And they're a bit boring, aren't they, on the IGCSE Cambridge courses? It's always the same numbers. So the magnitude of AB is equal to the square root of 6 squared plus 3 squared. You just saw this calculation 2 times already. Hopefully you're sticking with it. 36 plus 9 is square root of 45. Notice here they don't ask to actually simplify it down, so I suspect root 45 is a perfectly fine answer. But if you want to simplify, of course, we've seen this process, the whole root 9 times root 5. So you could simplify this down, of course, to 3 root 5, but it didn't indicate that in the question. Right, so now we've got the point C has coordinates 10k, where the length of AB is the same as BC, or AB is equal to BC, and k is greater than 0. Okay, and we need to show that k is equal to 11. Okay, so this is a bit more of an in-depth question. So let's come over here, for example, where this could be our point C, again, not to scale by any means, where this is 10 and this is k. Let's join this up as well. And we know the length of this line is the same as this. So AB is equal to BC and k is greater than 0. Okay, so there's a couple of ways we can do this. 1 to 7. We need to show that k is equal to that. Right, so let's have a think. Right, so we can actually work out the distance in terms of k here. So imagine I draw a right angle triangle. So I think I'll zoom in on this, so this specific section. So we've got C here, B here, where this is 7, 5. This is 10k. And we know this is equal to the square root of 45 because we're told it's the same length here. And we can actually work out these lengths in terms of k here. So we know that this length is the difference between 7 and 10. So that's equal to 3. And then the k, this part here between 5 and k, well, the distance between that is 1 take away the other. So k minus 5. Now this is where the k is greater than 0 comes into play, because we have to assume that k is, k minus 5 is that. And then at this point we can then just use Pythagoras. So we can say that k minus 5 all squared plus 3 squared is equal to square root of 45 all squared. So this is just using Pythagoras here. At this point we can just do some expansion here. So remember, k minus 5 times itself, k minus 5 times k minus 5. So we haven't used some FOIL yet in this video. So remember, first, outside, inside, last. K times k is k squared. K times minus 5 is minus 5k. Minus 5 times k is minus 5k. Minus 5 times minus 5 is plus 25. And again, this simplifies down to k squared minus 10k plus 25. So let's pop that in where the k minus 5 all squared is. So k squared minus 10k plus 25. 3 squared is equal to 9, that's fine. Now one of the beauties of using surds is that when you square it, these two things just cancel and you're left with 45. So it looks like we're going to get a quadratic here. Let's carry on. So we get k squared minus 10k. 25 plus 9 is equal to 34. 45. Right, and we want to get the right-hand side 0 for a quadratic. So what's the opposite of plus 45? Well, I want to minus 45 on both sides. If we do that process, this cancels. So we get equals 0, which is great. K squared stays the same. Minus 10k stays the same. 34 minus 45 is equal to minus 11. And this is a quadratic. Obviously, we can solve using the quadratic formula. I like factorizing. Makes everyone's life easier. So put a k at the front, k at the front. And we want two numbers here that multiply to give me minus 11, but add to give me minus 10. So that's going to be minus 11 and plus 1. So following those two rules. And therefore, k has to be either equal to negative 1 or positive 11. We're told k is 11, so that's kind of helpful. Remember, k can't be less than 0, therefore the -1 solution does not work, and therefore k is equal to 11. That's a nice question. Again, they try to integrate some quadratics into that, and also this so-called distance formula that at IGCSE you're not given, but IB you are given, so that's kind of confusing. Right, there's the mark scheme, so you can have a look at what I've done there. They've done it slightly differently to how I did for 10C, but of course they got to the final answer of 11 as well. Right, let's continue. So question 7, the vectors A and B are shown on the grid, and on the grid below, draw and label the following 3 vectors. So first of all, we need to do 2 lots of B, so we need to do B and then B again. So let's have a think about this. So if we start here, then we're going 2 along and 1 up for B, but then we need to do the same thing again. So 2 along and 1 up. And so this entire vector here will be equal to 2b. So 2 lots of this. Next one is 2a plus b. The tricky part is making sure this all fits in, of course. So let's do this one down here. So I'll start with the 2a. So a is basically just 2 up. If I just write it in straightforward language. So we've got 2 up. So that's a. We go 2 up again. And then we've got plus b, which is 2 along and 1 up. 2 along, 1 up. And so our actual vector that we're looking for here is going from the start to the end. So we need to pop in this arrow here. And so this vector here represents 2a plus b. Okay, I probably should just put this in black so it's clear to the examiner. This is my answer. All right, the last one here, start in red first. So doing a and then minus 2b. Okay, let's start over here. So we'll start with the a, so that's just 2 upwards. So starting here, we go 2 upwards, that's our a vector. And now negative 2b, so we want to go 2b but in a negative direction. So we want to go, instead of 2 right and 1 up, we want to go 2 left and 1 down. So 2 left and 1 down, and then 2 left and 1 down, like so. And so our actual answer is going from start to finish directly, which is this vector here with an arrow in this direction. So that's going to be a minus 2b, like so. So just make it very clear to the examiner exactly what your answer is at the end. Perfect. And on to question B. So vectors P, Q, and R are drawn on the grid. Write each of the vectors in terms of A and or B. So we don't have to write something A, something B. It could just be A, it could just be B. So these kind of questions, they kind of lead on from what we've been doing already. So if we look at this one here, the first thing I notice is if I take a section of this vector here, so this red part that I've just done, that is the vector minus b. Notice I'm going against the arrow here. So it's the same vector as this, just in a different direction. I've got 1, 2, 3 lots of it. So this is going to be minus 3b, because you've got 1, 2, 3. Minus b, minus b, minus b. This one Q, let's have a look at this one. Is there anything we can use to help us out here? Well, this is essentially 2 along and 3 upwards. I don't know if we've got a vector that's done that already. We've got 2 along and 5 upwards. Okay. Oh, there we are. So this is the vector upwards. Okay, let's start with the vector going upwards and see what we can do from there. So if we start here, let's go up A. Let's go up again A. Do you want to start B at this point? No. No, okay, we need to go 3 upwards. So this is A, because A is straight upwards. This is A again. And from here, we just need 3 lots of B in the correct direction. So 1, 2, 3. So I'm just seeing how I can break it down into the constituent vectors. And that means we've got 3a plus 3b. That's quite hard to spot in the exam, at least under pressure. R is actually more straightforward because we already did a vector very similar to this. Notice we had this vector but going in a different direction, because this is 4 units and it's going left, where this is 4 units and going right. So all we need to do is take this vector and flip the signs. So just do minus a plus 2b. In some ways that's the easiest one actually to do here, because we already got one of the vectors kind of like that already, and all we had to do is then flip the sign for the different direction. Okay, so you can check your answers there, so of what we've gone through. And let's do our final question for today. So this again is a short answer question here. Another magnitude question, we'll come back to that. A minus 3b, so let's just write this out. So 6/8 minus 3 lots of 2 minus 8. And let's work this out first on the right hand side. So minus 3 times 2 is minus 6. Minus 3 times minus 8 is positive 24, so be careful. And then if we add these together, we get 0 at the top. 6 minus 6 is 0. And then 8 plus 24 is equal to 32. So pop that in like so. And you've seen it again, the 2 lines. You know what that means. That means magnitude. And you know what that means. That means Pythagoras as well. So just writing that in as a reminder. So to work out the magnitude of A, we want to do Pythagoras on this vector. So we do the square root of 6 squared plus 8 squared. It's a nice number at the end. So let's work our way through. That's why there's no surd mention. 6 squared is 36. 8 squared is 64. 64 plus 36 is equal to 100. And the square root of 100 is equal to 10. If you spotted that Pythagorean triple of 6, 8, 10, then well done you at home for spotting that. That's going to save you time in the exam. Okay, there's the mark scheme. So that's my walkthrough of all IGCSE questions vectors. And we've also done a little bit of coordinate geometry in there as well, a little bit of quadratic. So as you can see, sometimes I like to integrate a different topic into it as well. Again, if there's a particular topic that you want me to go through, then please do let me know in the comments below. I'll be more than happy to have a look at that particular topic. Right, bye-bye for now.